Okay, I have 7:37 p.m. Can you tell me how many people are in the room?
There's 1, 2, 3, 4, 5, 6, 7 in here, and Marty is outside in the hallway taking a phone call. So we have
Okay,
7 here.
so eight, or including Marty
7 including Marty,
and you.
correct.
Thank you. 7:37, if you'd like to call it to order.
Yep. Let's go
We
ahead and
have
call the
fifth,
meeting to order.
we have 15 on Zoom, but it's really only 13 due to two double entries.
All right, cool. All right, can you guys see my screen?
Yes, sir.
Yes.
All right. And we're gonna go ahead and get started with the October meeting. We're not really gonna sing happy birthday, are we?
After adjournment.
Okay. Pressure's on.
There's no need to
All
record
right,
that.
no need to record that?
No,
No, we won't record, and after the speakers finish, we stop recording.
Is the recording on?
Yes.
Okay.
Dave, you're recording too, right? Just nod. Dave, you're on mute, so just nod.
I got recording on there, so
You're recording.
red
Okay.
dot, so I don't know.
You're good.
Okay.
All right.
All right, all right. We're gonna go ahead and
Logistics,
get, first thing we're gonna do is our presentation.
logistics in the 20.
Presenter today is Tom Hoffelder. Lots of accolades for Tom, but he's a ASGH past member, author of the Right Angle Sweep article in our online articles, and his presentation today is on meteorites, their origin, their composition, their varieties. Very dramatic title here. They came from outer space. So Tom, if you want to go ahead and I will stop sharing my screen. You can go ahead and start sharing yours.
Okay.
And it's all yours.
See if I can do
Thank
that.
you.
We did it once, right, John?
Yes, we did.
See if it
And I
works this time.
think I even recorded it so we can prove it.
Good plan.
Okay, did you click the audio
Hold
part
on.
or the video part too?
Again?
Yeah, every time you share it.
Oh, well,
Close it and start again. Sorry.
no, that's all
Stop
right. It
sharing.
says optimized. It's there.
Oh, well, how about
It
that?
was already there.
Color me stupid.
According to what it was clicked.
Very good.
Let's see. Come on, get out of the way. How do I get this thing on the top out of the way?
What is on the top? I can't, you're all
wait a
grayed
minute.
out.
Let me try this.
I can't see what it
Okay.
is. It's grayed out.
You can't see the thing now?
We can't see the what's on the top. There it is. It went smaller.
Oh. I don't know why that's there.
I don't know what it is.
Anyway, okay,
Anyhow,
so we're ready. You can see
you're ready. Go for it.
Okay.
Yes.
Yes, they come from outer space. Subtitle Meteorites and You. So let's go. This is pretty basic. Most of you guys probably know this, maybe all of you, but sometimes, some people, and if there's, people new or whatever, a meteoroid is out there in space, a random, relatively large rock, but when that means bigger than a grain of sand, which will cause a meteor, but we're talking about ones that can end up creating a meteorite, which means it has to be big enough to survive the fall and the hitting the atmosphere. So when you see a meteor, the rock slams into the Earth's atmosphere at thousands of miles per hour. And I always like to say it's like hitting a brick wall, even though it's only air. If it's a good sized one, on the night side of Earth, you'll see a bolide, which is that first picture there. That that happens to be at the Okie-Tex Star Party a few years ago, a star party that I used to go to quite often, and that was one of the years I didn't go. And then sometimes they're bright enough that you see a daylight meteor. So now you've got a rock that makes it to the ground, and now you have a meteorite. And studies say that 10 to 20 land per day, but very few of them are found. For one obvious reason, about 2/3 of them go into the ocean. We had 2 falls here in Maine in the last few years. Both of them went way northern Maine, which is all lakes, rivers, trees, leaves 10 feet deep. There's just no way. So that's why not very many of them are found. Excuse me. So the asteroid belt, as you guys, I'm sure all know, it's between Mars and Jupiter. And that's where all of our meteorites. What did you say? Oh, sorry.
No one said anything.
Oh, I thought I heard something other than me. Could have been. So the asteroid belt is where these rocks that end up being meteorites come from. There, I know it seems like we used to say that, oh, that's a planet that couldn't form, but there's only 4% of the moon's mass there, so there's very little. But there probably was a lot more to start out. But because of Jupiter's big effect there, all that mass on the other side, a lot of the stuff got kicked out of the solar system, not just out of the location. So a lot of the mass was lost there. But because of Jupiter, and more so because of the interaction between so many small planetesimals, rocks, whatever, out there, they end up hitting each other or passing close to each other, and that alters their orbit so that it comes towards us. And those are the near-Earth asteroids, like the dinosaur killer. There's 3 groups of these that they track. All come within 1.3 astronomical units of the sun. The first group, the Amors, they do not cross the Earth's orbit, but they come that close. You can see in this picture how they got the sun, the Earth, Mars, the red circle, and you can see the Amors and the Apollos go out far enough that they go back to the belt, the asteroid belt. Now, the Atens do not. They have orbital periods less than 1 year, so they're pretty much almost within our orbit, but they cross it twice. Now, of course, this is just 2 dimensions. There's 3 dimensions out there, and some of them are, of course, above the plane and some below, and they go across it. Now, collecting meteorites, I mean, yeah, meteors, that'd be fun. John, you sent me that article about, it was from the reflector, the Astronomical League's reflector of December 2016.
The author is here the author is here tonight.
Oh, hi.
It's Greg Shanos.
Yeah, it's me, the birthday boy.
Oh, okay, cool, very cool. So because I'm a rock collector, and I know John knows my email and my license plate says Rocks and Stars because I do astronomy and collect rocks. But I don't buy rocks. I find them. So when it said collecting meteorites, I thought it was talking about going out in the field and look for them, which to me was like No, probably not, because the odds are you're not going to find one. But in looking at the article, it was about buying meteorites, if I read it correctly, which a lot of rock collectors do that too. And in your article, you mentioned, I don't know how, 2016. You mentioned that lunar and Martian meteorites back then started at around $1,000 a gram versus $43 per gram for gold. And I don't buy rocks, I say that, but every once in a while I buy something that I'd like to have that I know I'll never find. So I bought a tiny piece of the moon and a tiny piece of Mars. And the main Mineral and Gem Museum, which I'm going to be mentioning more than once here, which has a meteorite collection. They were both about $50. And I don't know if I can't read the size there, but I figured that the lunar one only cost me $2.20 a gram. So I figured that was a good deal, although it's tiny, tiny, tiny. And the Martian was 800. So that was closer to 1,000.
I can read the gram size if you want.
Well, if you guys can read it, that's fine. But I just, I calculated it out. So don't look at it too close because I might have calculated it wrong. I don't think I did. Okay, so, and one of the reasons of the lunar, I'll tell you that later. So there's two general types. Falls, meaning they were seen to fall, or you saw a bolide, you saw something, and yeah, it looks like pieces probably landed, or the results of meteorites that landed that weren't necessarily seen to fall. And the other ones, most of them are found by just randomly looking around places where it's easy to find them. And that's mostly Antarctica, which all the ones down there, I believe they can't be sold. They have to stay with the universities or countries, whoever finds them, or the Sahara Desert. And that is a big place these days. Everybody's out there. Well, the people that live there are out there looking for them. Okay, so now the Stifler meteorite collection. So there's this little town north of me called Bethel, and it has the main Mineral and Gem Museum and the Stifler meteorite collection. And this, Larry Stifler, one of the founders of the main Mineral and Gem Museum, what happened is him and his wife bought thousands of acres up here years ago. They live in the Boston area. And they bought all this land because they just loved it so much. And most of it's in land trust now. But they found out that they had some of the famous mines, world famous mines, where tourmaline and things like that were found. So I'm a little off the subject here, but what happened is when they found that all, they didn't know anything about minerals. They decided that they needed to build the main Mineral and Gem Museum in Bethel because it's kind of the center of where all the old quarries were. Well, they're still there, but that's where the tourmaline is mostly found. And then Larry, being kind of a space nut, I mean, he's got all kinds of stuff. He's got a hard hat from the Apollo days that has, if not all, nearly all signatures of nearly all of the guys who walked on the moon, plus Wernher von Braun's signature.
Wow.
So when he said, "Oh, we're going to build a museum," I think we should do a meteorite room, and that was like 10, 15 years ago, maybe. And he started collecting the meteorites for it then. He only had a few, But now he has at least, this is what we always say, because I'm a docent there. And when people come in, we always say, this is the largest private meteorite collection in the world. Now, John kind of questioned me on this, and I think maybe we should say largest private personal meteorite collection, because it all belongs to this one guy, Larry. It's an amazing place. And I'm going to be using things in there for the talk, and it's going to sound like an advertisement for the place. And it kind of is, because we're not, it's, you wouldn't come up here for one day, but it's a unique place. And anybody involved in astronomy, I think, should try to get here. So the falls, these are some of the things in the museum that they have that are examples of falls. And these three, including the bottom one there, which was in Weston, Connecticut, these three were all around the turn of the century, around 1800. And before that, the scientists, they often heard from people telling them that rocks fell out of the sky. And the scientists said, there's no way. There's no way. You don't know what you're talking about. But after these three, which so many people saw, the two in the top were in Europe, and the one in Connecticut, so many people saw them. They picked up so many pieces that the scientists then decided it was time to start studying meteorites.
Excuse me, Tom.
Yeah.
Your audio is fading in and out a little bit. Is that?
Well, maybe if I move the phone a little bit here. Is that better?
Yes, sir. Thank you.
Okay, sorry. I thought it was interesting that Connecticut got in on the deal, and one of them landed there, and that was the first documented fall or find of meteorites in the United States, and the beginning of the study of meteorites here. Okay, speaking of Connecticut, this is another example of a fall, and it has the roof. It went through the roof of a house. So the first time I walked into this room, the meteorite gallery, I saw this and I thought, oh, must be one of the Wethersfield ones. And then I looked, and it's not. I'm sure you guys heard of the Walcott one, but I hadn't, because we were living in Maine by then. So this was the third meteorite that went through a roof in Connecticut. And when I'm a docent there, since there's nothing there, the other two, I tell the people about the fact that this is the third meteorite that's gone through the roof.
Yes, and we have an ASGH connection to the two Wethersfield ones because of Charlie Hammond.
In what way?
He was a scientist from Trinity University that was doing the investigation. And Bob, might be able to add more to that. His son Bob is here tonight.
Yeah, hi, I'm Charlie's son, and my dad was first on the scene on one of the Wethersfield meteorites, and it's now in the major part of it's in the Smithsonian, but I actually I have a piece of that, a sample of it
Cool.
in my
Excellent.
collection. I'm not sure what to do with it, but I have it. It's not very big.
What'd you say? You're not sure what to do with it?
Yeah, I've got a fairly substantial collection, and trying to figure out what to do with all of them. But
displays.
You need to display it so people can see it. I may donate it to a museum.
Well, yeah, that's an option, sure.
Yeah.
Okay, another example at the museum. The only killer meteorite known that's been verified. There are other stories, but they're kind of questionable. This one came down in Venezuela in 1972 and killed a cow. there was three pieces. The biggest piece, which is in the top picture, the bottom piece is a chunk of probably the biggest piece. You can see it's been cut. That's in the museum under one of the bubbles that they have most of them in. But whenever there's kind of young kids, like especially boys, I always point this out to them, and they go kind of crazy. They think it's great. Okay, another one.
Ah, yes, I remember this one.
Remember this one?
Yes.
New York, 92. The most photographed fireball ever, because it was Friday night high school football. And everybody had they were photographing the game, and all of a sudden there's this stuff in the sky. And it was photographed as far away from Peekskill as Ohio and North Carolina. And so well, there's a picture of the car, which the museum doesn't have, but it does have a small piece of the meteorite, the title to the car, and the tail light bulb that was broken.
Oh my.
So, okay. So next, this is the big one. This is the video. Can you see it?
Yes.
And you guys probably remember this one too. This part
Galavinsky.
right here, where it gets so bright. February 2013. Now, a lot of you find this stuff online, and you're supposed to share something that says where it came from. So I did on this one, and I just thought, yeah, okay, what does that mean? But in general, I think, stuff's online. Yeah, you put it there.
Shattered windows and everything. Oh, there, right there.
Yeah, they have a video. They have a video in the museum, in the meteorite gallery there, that it has a lot of stuff from Chelyabinsk, and it also has the videos of the one that hit the car and other things like that. But some of the pictures, some of the video that they have there is amazing, and I couldn't find them online. But it shows people in the street being knocked to the ground. And yeah, if you can knock the top off of that building, it would knock people down too, I'm sure. And all the glass, and that's how the 1,000 or how many of you it was that got hurt. When it exploded, that big explosion, it was brighter than the sun. So all of a sudden, the sky was brighter than daylight. Which made people run to the windows. And then the shockwave hit. Light goes faster than sound. So if you see a really bright light in the sky, don't go to the windows. But you guys know that. And then the biggest chunk happened to land in the lake. I forgot the name of the lake. That's not too far from the town. And they were able to get it out, the big piece out. I think it was maybe half a ton or something like that. So it was, they figures approximately 60 feet in diameter. The meteoroid weighed 10,000 tons, hit the atmosphere at an angle of 18 degrees with a speed of 42,000 plus. It's probably a good thing it hit at 18. If it had been steeper, it might have, the big piece might have hit a town or whatever. Briefly brighter than the sun, as I said. The energy was 26 to 33 times that released by the Hiroshima bomb. That's a lot of power. Wow. And so I only heard about Chelyabinsk, but 6 cities there were damaged, and it blew out windows over 200 square miles. 1,500 people injured. The largest known natural object to enter the atmosphere since the 2008 Tunguska event, which they never did find anything from that. So everybody thinks pretty sure it was a comet, not an asteroid. The only meteor confirmed to have resulted in human injuries. Can you still hear me, John?
Oh, yes.
Okay.
Fascinating.
Okay. So here is Chelyabinsk in Maine.
Whoa.
He has one of the windows with the glass broken out of it. And it's kind of hard to see, but that top piece, which made the shadow, it wasn't easy taking pictures in there. Made the shadow, and behind it is about the size of a fist. And then below it are like almost 100 tiny pieces.
Oh, that's not rubble. Those are actually pieces of Chelyabinsk.
Oh yeah, those were all meteorites.
Wow.
Yeah, yeah.
I'm starting to really like this Larry guy.
Yeah, he's pretty cool. Um, so there's falls and fines, but then there's three basic classifications. Stony meteorites, and there's two types: chondrites and achondrites. You can see chondrites are by far the most common. Then there's iron nickel, only 5% of all meteorites, and stony iron, which I don't know what the percent is, maybe 2/10 or something, because out of 70,000 meteorites, and these are falls, not pieces, there's only 158 stony irons. So they're incredibly rare. Now, can you see my arrow?
Yes.
Okay. So this is why there are three different types. The iron ones come from the core of a body that was, the whole thing was broken, and then the stony ones come from all the crust and the mantle of the body, and the stony irons come from only the boundary between the mantle and the core. So you can see why there is so many more of these, few of these, hardly any of these. Now, the three main classifications, there must be at least 10 different levels for those, and it's like, unless you're gonna really get crazy about it, and there's nothing wrong with that, and you had a lot of that in your article, but I just felt that was a little too much for here, because I just wanted to hit the basics. So that's why I didn't go into all those details. Okay, the chondrites, the two stony types. The chondrites are early. They're from they're the earliest rock you can have, because it hasn't been modified by being melted or smashed or anything. It has these chondrules. That's why they're called chondrites. These little round things. These formed at the very beginning, when the solar system was starting to form, and so it was just, tiny clumps of stuff getting together, and eventually, they attracted each other, and then you had some asteroids, but and so that was everywhere. But where there's planets, that stuff got all destroyed. But out there, some of it's still there, untouched, and based on, I don't know what, they figured that this happened. The beginning of the solar system, when stuff started coming together, was 4.567 million years ago. A convenient number, 4, 5, 6, 7. Chelyabinsk was a stony chondrite, a stony meteorite, and that's what most of them are going to be, because it's 85%. Now, the achondrites are also stony, but they've been melted or recrystallized by whatever means, so that those chondrules have been mushed into the rock, and you can't see them anymore. And so this rock isn't as old as the chondrites. Now the iron nickel ones, they're mostly iron with 5 to 25% nickel. So as I saw in that little picture of a planetesimal, they're from the core. And this one down here, I don't know if you can, well, in the blow up here of this one, there's what's called a Widmanstatin pattern. And that shows up only in iron nickel meteorites. And to see it, you of course have to cut it and polish it and then acid etch it.
So that's only a cross sections when they show up, and then acid etched on top of that.
That's right. Yeah.
I wondered about that.
Yeah. Now the one up here, and some of them in here, like this one, is one big crystal. And I don't know if you can see it, but sometimes it's a crystal. Sometimes there'll be more than one. In this one, there's kind of a line here, which means this is a crystal and this is a crystal. Now, if they haven't been cut, they look like this, although this is an extreme case. They're usually plainer than that. They call this, some of them get named, they're natural art. They call this one the mask or the alien. And meteorites are pretty expensive to start with, but when they look like this, art collectors buy them and the price quadruples.
How big is that? Those bottom two pieces?
The mask, you mean?
The mask and the one in the lower left.
The mask is about 6 to 8 inches.
Oh my!
Yeah, it's good sized. This is a whole case of the iron meteorites. So the bottom one is, bigger than that, and that's actually small. That's a small piece. That the bottom one that's been cut and etched. That's a small piece off of a much bigger one.
Wow. I'm sorry, I'm the only one asking questions. Is it okay to interrupt you for questions, or you want to pause, test?
No, do that
Okay.
because you might. If it was me, I'd forget the question by the time I was done. So, yeah, no, I encourage that.
Okay.
Okay, so I've learned a few things here while I was, studying up on this. Yeah, I'd look at things look online. And so I knew about the one from Willamette, however you say it, Oregon, which is the largest one found in the U.S. and it's at the American Museum of Natural History. So I've seen that one years ago.
Me too.
Weighs about 34,200 pounds, 10 feet by 6'6" by 4'3". Now, this other thing I never heard of. It's called the hobo because it landed or it was found in on a farm by that name, and in Namibia. And the mass is estimated at more than 65 tons. That's now. They think at least a ton of it has been carried away. It's 8'10" by 8'10" by 2'11".
8 foot.
The really weird thing is there's no crater there. Well, there was no crater at the Willamette either, but they figure that came down from Alaska in a glacier. So that's understandable. But how do you drop something that big in the earth with no crater? I don't know. And I'm not going to say aliens.
Where is that one? Is it still in Namibia?
Yeah, it'll be there forever. 65 tons.
Larry didn't buy it.
No. No. So this is about something that just happened as far as this mission. I don't know if you guys followed it.
I sent so many emails to ASGH about this. They're sick of me telling them about it. But I didn't say anything about it after they launch.
Oh,
so feel free.
Okay. There was two really big things going on at the same time. That that stuff coming back from Bennu, was it? I think that was the name of it. That
Osiris Rex.
Yeah, that was so cool. The whole thing. Now it's on its way somewhere else. Okay, so anyway, Psyche. It's the asteroid is a main belt iron nickel asteroid, and most of the asteroids are a mix of everything, but somehow apparently this thing lost its outer crust, and that's why they've been interested in getting close to it. Its average distance from the sun is 3 astronomical units, about 150 miles in diameter. Apparent magnitude 9 to 12. So we could see it in our scopes. And it's number 16, which means it was the 16th one discovered.
Mm.
Now, the mission was launched last week, the 13th. Yes.
Mm-hmm.
It's going to go by Mars to get a kick in 2026 and should arrive at Psyche in 2029. And the really cool thing about it is it's going to give us some idea what the core of the Earth is like, which we'll never be able to get to. But here we might have some way of seeing it, get some ideas about planet formation. Wait a minute. Did I miss something?
Just before you go on, I attended the live talk about the launch and what they're studying. I don't know how many people else here did. But spectroscopy is going to be, and a magnetometer is their main tool for this mission. Because it is so magnetic, from pieces that have fallen in their estimation.
Yeah, that's going to be cool. I think I might have stop me if I already said this, but I think I forgot to explain something. So when I knew for years, I've known about metal or about iron nickel meteorites, and it was kind of a mystery to me because I always thought, well, don't you need a kind of a really good sized body to get an iron core? But I found out when I first went to the museum, they gave us a little class about meteorites for the docents that go there. And it turns out that in the early stages of the solar system forming, there was a lot of, I want to say, aluminum-26, which is very radioactive. And it created so much heat in small bodies, like maybe only 30, 40, 50 miles in diameter, that they would end up with a metal core. Now, this one, of course, is bigger than that. But like that, back to that original thing that showed where the iron and the nickel iron and the stonies come from, that didn't have to be a very big body. And it would have a metal core. So, okay, so these are what the stony irons look like. And they are like really cool looking.
Olivine.
Yeah. So they're a mix of, they have the nickel iron. That's kind of, well, in the really big one there at the bottom right, you can kind of see that. Unfortunately, there's a big reflection there. But you can see the silver, which is the nickel iron, and then the rest of it is kind of glassy, which is the olivine crystals. And the one up, well, this one and this one, the same one, I just enlarged it a little bit. This one and this one too, but you can't tell it. They're real thin and illuminated from behind. This big piece is the largest piece of a palisite. They call these palisites after the German guy who first studied one of them. His name was Pallas. So a lot of people think it's named after Pallas, as one of the good-sized asteroids. That's not what they're named after. They're named after a guy named Pallas. But this is the largest known piece of a palisite because it's the center cut from the largest known whole chunk of a palisite. And it's about at least an inch, maybe 2 inches thick. And they're talking about cutting it so that they can illuminate it behind it, but scare the heck out of me to try to cut that. What if you break it in half? Then it's not the biggest anymore. Along these are three that they have there that are not in behind glass or whatever, one of each kind: a stony, an iron, and a stony iron, which you really couldn't tell. It looks a little gnarly compared to the other ones, but it would be difficult to tell without cutting it. I also forgot to say something. I need to go back. You can see a little bit on this iron, but I need to go back to the irons. Okay, so another thing I always thought was, okay, you get, this is an extreme case where you have holes through the whole thing, but it's kind of thin, which is why. But I always thought, well, okay, it's iron nickel, it melted when it came down, but maybe a little bit. Most of that is in this one, the big one below it, and the close-up of the big one below it, you can see this brown stuff. And that is actually a type of pyrite. And it's very soft. And if, if like there's some right, well, here's a piece of it. If it's near the edge, it will wither out if the thing is laying around for a while. So that's how a lot of those weird shapes end up. Something else I learned there. Okay, where am I here? I'll go back to this.
Here.
Okay. Now, so in case you think you found a meteorite, so you're walking along, you're used to seeing rocks. All of a sudden you see a rock. It's like, where the heck did that come from? That doesn't belong here. So people think, oh gosh, I wonder if it's a meteorite. Well, these are the checks, basic checks that you can do to get an idea of whether it's a meteorite or not. They're very dense. They're magnetic. Even the stony ones are magnetic, not as much as the iron ones. But like it says here, instead of trying to get it to stick to it, you hang the magnet from a string, and you can see if it will be attracted a little to the thing. Of course, there's a lot of earth rocks that are magnetic too, so that isn't going to, and dense too. So that's just the begin. This is the beginning. You still might have an earth rock, unusual shapes, rounded. The iron ones have these pits in them. So that's not so much earth rocks. Now the fusion crust. So the picture on the top here, that's a fusion crust. They're really pretty black, and the stony ones do that when they come down through the atmosphere. The problem is you're not going to see that if it's been laying on the ground very long. These down here are stony meteorites, but they've been laying on the ground for a while, and the fusion crust goes away. So you're not going to see that unless you're out looking for ones that just fell. Things meteorites do not have. They don't have light-colored crystals. There's no quartz crystals in meteorites. There's a lot of it here, but for some reason they're not. Well, the conditions aren't right for quartz crystals to form. Bubbles. If they have bubbles in them, they're not meteorites. That's metallic slag or volcanic rocks. Streak is a way to different minerals, different rocks give a different streak color. If you scratch it or scrape it on unglazed ceramic tile, and if it leaves a streak, then it's not a meteorite. So those are the first things. There's one more check. We'll get to that later. Okay, so Vesta, why do I have all this junk up here at the top?
A check came through.
Oh,
It'll go away.
okay. I won't. I'll ignore it. So asteroid Vesta, the fourth one discovered, the second largest one. Average distance from us, or from the sun, I mean, about 2.5 astronomical units, 325 miles in diameter, but it's not very circular. Apparent magnitude of 5 to 8.5. So theoretically, it's visible to the naked eye. I've never been able to see it, but I've tried.
Mm.
It was discovered in 1807 by Heinrich Olbers. And again, spacecraft, this was back a while, the Dawn spacecraft, arrived there July 16th, 2011, and a little over a year later went to Ceres. So those two asteroids got a lot of pictures. Well, this one got pretty beat up. And this, I never saw this before either, but obviously they call these three craters the snowman. That's something else I learned while I was looking for all this stuff. I'm gonna have to put that on Facebook. So Vesta. So Vesta in Maine. All the meteorites from Vesta are stony achondrites. So they don't have the chondrules. There's 3 types. I got a little wild here and came and used the 3 names of the 3 types that are from Vesta. Howardites are from surface. Eucrites also from the surface, but they're igneous instead of just non-igneous rock. And diogenites are igneous, but from deep within the crust. So all of these here are the case in the museum. These are all from Vesta. And this one, over here by itself in this cylindrical container thingy, is the largest piece known of Vesta on Earth. I should say it was the largest piece. There's a larger piece, but the museum has it, so soon it'll be beside this one. They haven't cleaned it up yet. So they got the 2 largest pieces of Vesta.
Wow.
The guy that they have this guy who's known as a buyer. He goes to Africa and places and finds out all the new ones that are found, and he works with Larry almost every day, I think. He called up Larry and he said, I got some bad news. He said, they found a bigger Vesta meteorite, but the good news is we have it. So lunar meteorites. So lunar meteorites come from the moon when meteoroids, they're not meteors because there's no atmosphere, hit the moon hard enough to knock stuff out of the gravitational field. And the studies have shown that an impact of craters of only a few kilometers across or less will eject stuff into the out of the gravitational field. Now, they're able to tell they can measure how long by cosmic rays, how long something's been out there. So this stuff was under the moon, so it starts reading this when it gets kicked out. And all of them that have been found have only been in space for 20 million years. But most of them left the moon in the past 100,000 years, because after they get kicked away from the moon, well, what's closer? Earth. So our gravitational field picks them up, and eventually they fall here. But there's not a lot of them. The total weight of the ones known now is about a little over 1 ton, 2,400 pounds. So they got here naturally versus the Apollo rocks that were brought back, which was 840 pounds. Now, the thing about the ones they brought back were all from just a few areas on this side of the moon. Some of the lunar meteorites have to be from the far side of the moon. So it could tell us something different. And a couple of the ones they have here at the museum are good candidates for that. And the museum has unbelievable machines, X-ray diffraction, whatever you want that you can work with rocks in the basement. And they're going to be doing some of that, but they're getting more things that are even more advanced. And people, guys, scientists, geologists, not well, it's mostly a mineral museum, but geologists and what do you call them? Meteorite people that study meteorites. They're all signing up to come and use the stuff. So the place is getting famous. They got a $750,000 grant from the U.S. government to buy that stuff.
Neat.
1 in every 1,000 meteorites is a lunar meteorite.
Not a bad odds.
Yeah, I just remember something I was going to say. So this is in Maine, right? The museum's in Maine, and when you read, let's see if this is it. Yeah, so this is the display of most of the lunar meteorites that are on display. This is most of it, but I don't know whether it's either in that writing or because there's also audio things you listen to, and it says all of the lunar meteorites on Earth could be put into 6 lobster traps. I guess because we're in Maine, that's what they say.
It is Maine.
Yeah. So the museum has the largest known lunar meteorite, which is right there under the words. And then the other 4 on either side of it are right up among the next 4 biggest ones. But this privately owned museum has more lunar meteorites than all the other museums, private, public, whatever, in the whole world.
Do you know what the largest piece that was brought back by an Apollo mission is? I know you said 840 pounds, but
yeah, I don't know. I just added up what each mission brought back, and I didn't see any information about the biggest one.
Well, come to think of it, I've seen the trays and they aren't large.
Yeah, I wouldn't think so.
That they put the samples in.
Yeah, I wouldn't think so. Martian meteorites. Same thing as the moon, but because Mars is bigger, it takes a bigger impact to get the pieces out of the Mars gravitational field. So you need craters that are tens of kilometers in diameter, not just a few. Okay, once again, I'm going to use some words here. Just like Vesta, there's 3 different types, and they named them sugatites, acolytes, and chazignites, and those are named after. That's basically the name of 3 different Martian meteorites. Meteorites get their name from wherever they land. So again, like Chelyabinsk, that's called Chelyabinsk because that's where the pieces landed, most of them. But so again, this cosmic ray thing shows that the Martian meteorites, when they check that, they're grouped into 8 different times, and the oldest one was 20 million years ago, and the most recent was 750,000 years ago. So obviously it takes longer for stuff to get here. And again, they're going to be even more rare than lunar ones. I copied this out of, I got this from different sources, but this statement here, the largest complete uncut Martian meteorite I don't know how to pronounce that. Again, that's the name of the place it was found in Mali in early 2021. Was recovered in Mali. It weighs 32 pounds and is on display at the main Mineral and Gem Museum.
I'll be darned.
And there it is, along with some other ones. So the biggest one there in the bottom, kind of to the left center. That's it. That was when they got that was big news, and they had a reception, and there was news people there and scientists. It was pretty cool.
Larry's buyer at work again?
Pardon?
Larry's buyer at work?
Oh, absolutely. Absolutely.
I'm impressed.
Okay, so now you may be wondering, and I get this question a lot. People say, well, how do you know that's from the moon? How do you know that's from Mars? And there's this little way of telling. For some reason, every planet, moon, asteroid, now has a different ratio of the three isotopes of oxygen. So they compare 16 to 17 and 16 to 18, and you get curve. It's not a curve, you get a line. And so you can see the line is all Earth rocks. Now, the moon, the circle, is on the same line, but it's only at this part of the 016 to the 018. And Mars, I think, yeah, this is Mars, is above that line. And Vesta is below the line and way to the back here. So in 82, an unusual looking meteorite was found. And they checked the isotope ratio, and it was the same as the Apollo moon rocks. So this was the first time they knew for sure that there were meteorites here that came from the moon. And I mean, once they did that, then they started checking, they went back and looked at old ones, all new ones they check. So that's how they found out that there were some from the moon. Now, we haven't brought any rocks back from Mars, but in 83, they found trapped gases in a sugartite, one of the Martian types, and it matched. They were able to get it out of there, and it matched the Martian atmosphere as measured by the Viking landers in 76. So now they knew what the Martian ratio was. Now, Vesta is a little different, but it's like 99% sure. And it's based on the fact that what's the next obvious object that you're going to have meteorites from? And based on the fact of how it looks, how it's been so beat up, and some other things from the Dawn mission, that there's just very little doubt that those are all from Vesta. Now, suppose you have this maybe meteorite, and it it kind of passed all the tests, or most of them. This is the final test. This is how you find out if you have a meteorite. You take it to the main museum, they check the isotope ratio, and they'll tell you whether it's an Earth rock or not.
Is there a charge for that?
$100. And if you pass all those tests, you got a good chance of making it. So I would say it's worth $100 if you can pass those tests. And there's even some in the museum, they call them, if they're not meteorites, they're meteor wrongs. But
that would be a perfect ending slide.
Oh, well, I'm not quite done.
How far are you, by the way?
Close.
Thank you.
Yes. So, or what was I going to say? Oh, okay. So they can check, and And people do come in, they go to the museum, they see meteorites, say, oh, I think I have one. And every once in a while somebody brings one in, and one has been found. One guy brought in a real meteorite. He had been using it for a doorstop for about 20 years. Okay, so I don't know. You probably can't see the words up there at the top, can you, or can you? The only place in the world where you can hold a moon rock and a Mars rock is the Main Mineral and Gem Museum, Stifler Meteorite Collection, because he has so many. Nobody else is going to let him out.
Wow.
But it's the only place in the world where you can hold a rock from the moon and a rock from Mars. And you can see the guys holding there, the little guy, the girls holding them is Mars. So you can get an idea of how big they are. That we keep them in that little case there. So what's next? So the moon and Mars. You get to hold them. It's the only place in the world. Now, okay, quickly. So because I do rocks, I also love that part of the museum. And just to get to the next part here, I wanted to show this is the kind of stuff's in there. And this is just very, very tiny part of it. The whole display is amazing. It's world class, absolutely. So I like those. But of everything in the whole place, this is by far my favorite specimen. And it's a meteorite. And it fell in Australia in 1969 near Murchison, Victoria. So it's called the Murchison. And there were a lot of pieces. But it's a special type of stony meteorite, the chondrite. It's a carbonaceous chondrite. And they are rich in organic compounds. Due to the mass, it was over 220 pounds, and the fact that it was an observed fall, the meteorite pieces was one of the most studied of all meteorites. And it was found to contain nearly 100 amino acids, including the 22 that we use. Many organic compounds would have formed in the early nebula, but the sun would have cooked them apart close here. The amino acids that were incorporated in the asteroids were safe, and the ones that ended up hitting the Earth, and there were a lot of them early on, that they seeded the Earth with amino acids. And that's why pretty much everybody thinks we're here. And the museum is the only place in the world where you can touch a piece of the Murchison. And this, you can't tell here, but it's only about 1 inch across. And actually it broke into 3 pieces because they're real fragile. So we put it in this little box and it's open on top, but just from touching it, it broke.
No.
But it's still the only one in the world you can touch. Now, the other slightly interesting thing, to me, not nearly as interesting as the amino acids, but it was recently found to have particles that were 7 billion years old. Tiny, tiny ones. Silicon carbide, which is very hard. So those were formed in the supernova, at least one of the supernovas that seeded the cloud that we came from. That's it.